All right, ladies and gentlemen, in this video, we are going to learn how to find the slope from the equation of a line and also from a table of values. Point A, warm up, find the slope. We have different scenarios here, given a graph, given coordinates, given a table, given a verbal description. When you're given a graph, you either have to find the coordinates by using your eyesight, or they'll be given to you, and then you just plug them into the slope formula y2 minus y1 over x2 minus x1. And you see in this graph we have -9, -10, and 3, 10. So step one is to label the points, plug them into the formula, and you get 5/4. Problem 2, given coordinates, you're given two coordinate pairs. Step 1 is to label those points x1, y1, x2, y2, and then plug them into the slope formula. And here we find that because these x values are identical, when we subtract them in the denominator, we get a 0, which is not allowed in mathematics, so m, the slope, is undefined, and this represents a vertical line. In problem 3, we're given a table. Process a little bit different. First, we find the differences between the x values. Here it's going up 4 each time. Then the differences in the y values. Here it's going up 7 each time. Then we take the ratio of those differences. Here it would be 7/4 each time, because the slope is the change in the y values over the change in the x values. So the slope is 7/4. In the final warm-up problem, we're given a verbal description. Comets fly through space at a constant velocity. At t equals 3 seconds, a comet is at position 8 light years from the sun. At t equals 9 seconds, the same comet is at position 6 light years from the sun. What is the speed of the comet? Is it approaching or retreating from the sun? Challenge: how long until the comet impacts the sun? I gave two solutions to this, the first of which is to make a table. And so we list the distance in light years. A second, my paper is stuck. Okay, in the first solution, we make a table, distance in light years and time in seconds, and then we just list the values. Distance is 8, distance is 6, time is 3, time is 9. We do the same thing we did above in the table. We find the differences in both the dependent and independent variables. Remember that the slope is the change in the dependent variable over the change in the independent variable, so this gives us a change of -2/6, which can be reduced down to -1/3. So the speed of the comet as it flies through space is -1/3 light years per second. In the second solution type, we create coordinate pairs. It's basically the same thing. Here I've listed 3, 8 for x, y. This is the time and this is the distance. And here again, 9, 6. Time, distance. Label them x1, y1, x2, y2, and plug them into the slope formula, and you get the same answer. The challenge question was, how long until the comet impacts the sun? And in one version of this solution, I say we know the comet is traveling towards the sun. It's coming at us because the distance from the sun is decreasing from 8 to 6. So it's 6 light years from the sun at 9 seconds. And we know how fast it's traveling. So I say set up a proportion. If the comet moves -1 light years every 3 seconds, that is, it's coming toward us at 1 light year every 3 seconds, then how long for it to travel -6 light years? So you set up a proportion. -1 light year over 3 seconds, that's the slope, equals, should be -6 light years over x seconds. That is, how long will it take for it to cover the distance, those 6 light years? So you do butterfly and you solve it out and you get x seconds equals 18 seconds. So it takes 18 seconds for it to get to us, or to the sun rather. Okay, and the second page of these notes, we learn how to find the slope from a table of values. The steps are: find the change in the dependent and independent variables, then calculate each ratio to find the slope and ensure the relationship represents a constant rate of change, which would be a linear relationship. Here are a couple of examples. Example 1, find the slope, and we're given a table of values listed vertically here in 2 columns. And for this table, we find the change in the x values. You see here those changes are not the same. Here a change in the y values, those changes are not the same, but the ratio of the y over the x values is the same. It's negative 2/5 each time. So the slope, change in y over change in x, is negative 2/5. Okay, here we have another table, but this one's listed horizontally with rows, and we're given distance and time. And here's some distance, and here's some time. So we calculate the change in the distance, that would be negative 3 each time, and the change in the time, plus 8 each time. And we remember that the slope is the change in the dependent variable over the independent variable. We know that time is always the independent variable, so we say that change in distance over change in time will give us the slope, or the speed, and we get negative 3 over 8 kilometers per second. Speed is just the slope. Okay, point C, find the slope from the equation of a line. There are three types of linear equations that you'll encounter often. One is the slope-intercept form, and it takes the form y equals mx plus b, where m is the slope and b is the y-intercept. Here's an example. You can really read the slope off the equation in this example. Y equals negative 2/3 x plus 4. Because m is the slope and y equals mx plus b, then negative 2/3 is the slope. Here's point slope form. Y minus y1 equals m, open parentheses, x minus x1, close parentheses. Remember, m is the slope, so here we have y minus 1 equals 5/8, open parentheses, x minus 3. We just look for the m position value, and that is the slope. It would be 5/8. Standard form is more complicated. You actually have to do something when you get a standard form equation. That's ax plus by equals c, where a, b, and c are integers, and that's no fractions, and a should be a positive number. To find slope, you have to solve for y in slope-intercept form. So here's the equation we're given, 3x minus 2y equals negative 15, and we solve by subtracting 3x from both sides, and then we set negative 2y equal to negative 3x minus 15, divide both sides by 2 to get y by itself, and then we separate those into separate fractions, negative 3 over negative 2x minus 15 over negative 2. Simplify out the negatives, you get y equals 3x plus 15 halves, and now we have slope-intercept form, so we can just read the slope, and that would be slope m equals 3 over 2. Finally, we have some practice problems here. Find the slope of the line, and we have all the different scenarios. Given an equation in slope-intercept form, remember, y equals mx plus b, therefore negative 3/5 is the slope. Given an equation in point slope form, y minus 5 equals negative 5/3 x plus 3. And again, in this is y minus y1 equals m, x minus x1, so negative 5/3 is the slope because of the structure of the equation. Number 3 is given an equation in standard form. Remember, you're going to solve for y and then make sure it's in the slope-intercept form equation of the line. And here we subtract out 9x, and then we divide by negative 7, and we get rid of the double negatives, and we have y equals 9/7 x minus 7. We know that 9/7 is a slope because of the position here of the m value, y equals mx plus b. And here we get given any equation. So we can have equations in x and y that are the most convoluted things you've ever seen, and all you have to do is solve for y and get everything arranged so that it looks like y equals mx plus b in slope-intercept form. So, here I solve out the equation for y, and we get y equals 7/2 x plus 4. So in that case, m equals 7/2, because the m position, y equals mx plus b, is 7/2. Little review here, we're given two coordinates, a line passing through 0, 2 and negative 5, 5. Remember, label the points. Label the points x1, y1, x2, y2, and then plug them into the slope formula, and you'll solve it out, and you'll end up with m equals negative 3 over 5. Okay, given a point and a slope, so here's the point you're given, and you're given a slope. So in this one, you would plug it into the point slope formula, and you just label these points x1, y1, and then plug them into the point slope formula. You also have your slope. So negative 2, 3, and slope m equals 1/2. Y minus y1 equals m, x minus x1 is the point slope formula. All you do is plug in your values. So here you would say y minus 3 equals 1/2, open parentheses, x minus negative 2. Get rid of that double negative, so y minus 3 equals 1/2 x plus 2. Add 3 out on both sides to get y by itself, and then you put this in slope-intercept form, y equals mx plus b, or y equals 1/2 x plus 5, and you can read the slope m equals 1/2 right off of the formula. Number 7, given a table, here we have a table of values. We find the differences in the x values, 8, 1, and 5, and then we find the differences in the y values, -8, -1, -5. Then we take the ratio of the change in y, that would be -8, -1, -5, over the change in x, and each time we find that the ratio simplifies down to -1, -1, -1. Therefore, the slope is -1. Finally, we're given a written description. At 8 a.m. there were 2 inches of rain. By 11 a.m. there were 7 inches of rain. By 2 p.m. there were 12 inches of rain. How much rain falls each hour? Solution is to make a table. Okay, so I listed out time and rain. So that would be time 8, 11, and 2. But remember, these are times. These are 8 o'clock, 11 o'clock, and 2 p.m. So the change in each is plus 3 hours. And then rain, you've got 2 inches, 7 inches, 12 inches. So it's going up by 5 inches. And then we take the change in the dependent variable, that would be rain, over the change in the independent variable, that would be time, and we find that the ratio is constant at 5/3, which is 1 2/3 inches of rain per hour. Okay, well that was the visual notes or video notes for this section. I hope you found it useful. Links are in the description and pinned comment. Leave a like if this was helpful, and make sure you subscribe to the channel so you're always updated to new videos. Thanks.